welcome to Programming Throwdown, episode number 2, Python. Take it away, Jason.
Hey, how's it going? So, how was your day today?
Pretty good. I'm practicing my radio voice.
Oh yeah? I've noticed that I turn to YouTube for learning just about anything. Like I wanted to cook snow crab, so I went on YouTube and I saw how to cook it. And then I'd cooked it, but the snow crab has a really tough, exoskeleton.
Right.
So I couldn't figure out how to get the meat out of the crab. So again, I turned on YouTube and put in how to eat the snow crab.
Our brains have been offloaded to Google.
Yeah, pretty much. Anything I need to know how to do, I've gone to YouTube. It's kind of sad. Pretty soon it's going to be like, how do I feed myself?
How to flush toilet.
Yeah, that's right. I'll flush the toilet. I need to figure out a way to pull my pants up. YouTube.
Oh no. So I do realize when you write stuff down, it's good, but you don't remember it. Like if I write something down, I never remember it anymore because I know it's written down. I don't need to remember it. So I guess once you look up how to learn how to eat snow crab, it's just always going to be online. You're never going to remember.
Yeah, that's true.
I saw a guy wrote a book. I think it's called Moonwalking with Einstein. Supposedly it's about a guy who tried to become like the world or the U.S. champion of memorization. And I don't know. I haven't read the book. I just heard about it. But it sounded interesting. I'm going to have to check that out because I've always wanted to have better memory. I'm pretty terrible at it.
Oh, nice. Did you see that Mathemagician on TED, on the TED Talks?
No.
Yeah, so this guy, basically, he built himself like a base 300 number system where like he took a bunch of words and he associated them with large numbers. So he can do like really amazing things. Like he's like, give me two 6-digit numbers and I'll multiply them in my head. And he does it by converting each of the numbers to, it might even be more than 300, but he has this whole lexicon and he knows that like slippers is 493 or whatever,
Wow.
And so he converts your number to some really high base and then does the multiplication in his head and then converts that.
That's a cool parlor trick, I guess, and really awesome.
Yeah. Yeah, this guy was like, he goes around just, I guess he's a motivational speaker too, or maybe that's all he does, but I guess that's how he makes his living.
Wow. Well, that's pretty cool.
Yeah, Mathemagics.
It's called Mathemagics. Okay. We'll make sure to link to that video.
Oh, yeah. It's a great TED Talk. It's one of the best. Well, it's more like entertainment than the other technology or design.
Right. But you tend to say that about almost every TED Talk you watch. This is the best.
It's true. It's true. It's like everyone you watch is like, oh man, this is life-changing. And then you get to the next one. Although, they've been going downhill.
Yeah. They franchised.
Yeah, they franchised, and now like the TEDx talks sometimes take the front page, and you can just tell the quality isn't there,
Yep. All right, well, you want to go ahead and get started with the news?
Yeah, sure. So what's your news story?
So the first news story I had was an interesting thing. Had a little bit of delay in recording this podcast, so saw this a while ago, but I thought it was really interesting that with the new version of the iPhone OS, iOS, I guess iPhone and iPad and iTouch, but Apple had an upgrade to their JavaScript engine, and I don't know if they started calling it this or this is what's always been called, but I guess it's Nitro. I think Google's is V8 or something, so everybody I guess has their own cool name for their JavaScript engine. But they made a bunch of performance updates to actually improve the speed of JavaScript on their iOS platforms, and it did a really good job, and everybody's pretty excited about it. But then people figured out that if you don't have an iOS device, you won't know this, but you can like bookmark a web page to your desktop basically, and run it from there. So like if you double click on it, it's like a hyperlink and it just kind of runs it in the browser. Oh, sorry, no. So you can do that. But I was missing. Some people just have apps that run basically websites from within the app. So they're kind of like an embedded browser or whatever, but they're really just like Google's works this way. So Google's app mostly just, references stuff on the internet. And if you're using, I think the way it works is if you're using the embedded browser instead of using, natively written iOS stuff, you don't get the speed ups that they gave to all the other Safari stuff. So it's kind of an interesting thing that they left that out. I guess it could be a bug, but people are suspecting maybe they did that on purpose.
So so the embedded browser, I guess it's just a completely different engine than Safari?
Well, it's supposed to be the same same engine, I guess. Like it's supposed to be a version of embedded Safari like within that app.
Oh, I see. So maybe it has more restrictions.
Right. I guess they were saying for possibly for security reasons or something. But I thought that was
Oh, I see what
interesting
you're
that
saying.
yeah, that they would, kind of cripple those. Interesting. Because you can do with the HTML5 stuff, you can do a lot of things that you would normally do in a native app.
Apple's always so paranoid about someone writing some app that compromises, either the hardware itself or even worse, like your information or your contacts or something like that.
Right.
So maybe in doing so, they left out, some of these updates.
Hmm.
I always felt like, there should be kind of like one browser engine to rule them all. Like, it's kind of starting to head this way with WebKit. Like WebKit is, I believe it's on the PlayStation, and WebKit is part of, Google Chrome. It's like the engine for that.
Yeah.
But yeah, there's no like just generic engine that isn't really tied to like a particular OS or anything like that. Like there's no web engine that just writes to OpenGL or something like that.
But I guess that's good because the competition between them, they drive features from each other. So kind of transitioning into our next topic, talking about the new release of Firefox 4 and IE 9, that they've both picked up, I guess, what was started with Chrome, I believe, with the tab styles, where instead of having the traditional file, edit, view, menu, whatever at the top, they just kind of have tabs at the top, and they get rid of a lot of that extraneous stuff unless you go looking for it.
Right.
So I guess that's good, right? Because if you only had one, it just would have always stayed kind of what it was.
Yeah, that's true. That's true. I think that because, what they want to do is tie into the theme of the particular operating system. So like in the case of Windows, if you change your theme, they want, to that theme to be reflected in your browser windows.
Which makes sense.
And so, yeah, and that's fair. But because of that, they're kind of tied to those particular OSs. So there isn't just some generic like write to a frame buffer or something like that.
Yeah.
Web layout engine.
So have you downloaded the new Firefox?
No, not yet. I want to. I have the beta on one of my machines, and it seems to run well. I haven't had any crashes or anything with it. But one thing I have done is in Google Chrome, I went ahead and changed my YouTube settings so that they use HTML5 instead of
Really?
Flash. That was pretty cool. They didn't have the like seeking in the video. I don't know if maybe I'm using too old a version of Chrome or something, but I have to play a video all the way through, which kind of sucks. But the support is there, and I mean it's using the the On4, I guess, video codec, or
Oh, right.
On1 or something
Right.
like that. And yeah, it works nice. Works well.
Yeah, so I've been using the Firefox 4 since, I guess it's like beta 4 or beta 5 or something. It's been a while, and I kind of went upgraded. It was even pretty good back then, and yeah, it's been nice. I haven't really noticed that much difference to going to the actual, now the full release. But yeah, I've been running it for a while, and things have been nice. A couple of the plugins I like to use haven't been ported over yet, I guess. But other than that, I've had no problems.
Oh, nice. Oh, it's called On2. On2 is the company that Google bought, and they created their own video codec called VP8.
Oh, yes.
Yeah, the interesting thing about it is there's no patents at all. I guess it's a completely different, setup or completely different algorithm than, H.264. And when Google bought it, they opened it up completely, which is really useful because anyone who's done video compression knows, or even audio MP3 compression knows what a nightmare that stuff is
Yeah.
with respect to patents and all that.
An interesting thing, I've long abandoned Internet Explorer, just been burned too many times in the past about terrible experience. But I saw with the new release of Internet Explorer 9, some of the JavaScript performance testing actually showed that Internet Explorer 9 is the fastest browser in the West.
Yeah, that's interesting. I wonder if, Microsoft decided to really kind of pick it back up because they have just gotten so much flack. Nobody seems to like Internet Explorer. And remember that thing on the White House where somebody asked Hillary Clinton if they could have Firefox in the White House? And she clearly had no idea what Firefox meant. I mean, for her, it was like she thought that something was burning.
You mean the internet? It's the internet? No, the thing you use to access web pages. Yeah, the internet. So.
Yeah, here, we'll link to this video. I'll put it in the agenda.
Okay.
But yeah, it's a staffer asked Hillary Clinton why Internet Explorer is mandated, even though Firefox which is free and is security approved. And her answer was that saving money is complicated.
Non-answer.
That's funny.
All right. So it looks like you got the next news item here.
Yeah, let's see. So, former Goldman Sachs employee goes to jail for 8 years. And so the deal is this guy, he worked for Goldman Sachs. He was making, let's see here. I think it was, yeah, 400,000 a year to write code for their high frequency trading applications. And so for people who don't know, there are, many of the financial institutions have computer programmers that go in and write software to trade at extremely high frequency. So what would you say, Patrick? Like nanoseconds or something, or
Yeah, I mean,
milliseconds?
sub-millisecond trading times is the stuff I've seen. I'm not an expert by any means, but it's really fast, like, hundreds of thousands of transactions a minute kind of stuff.
Yeah, insanely fast. And I think they do arbitrage, but they also speculate, right? In that short amount of time.
Yeah,
And so this guy is writing the software that, essentially becomes an arms race. Someone has this kind of software, and then he writes this, software that learns to exploit their software, and so on and so forth. They're paying him 400,000 a year, and
nice.
he decided that he was going to take his software over to a small company that they offered to double his salary. So he tried sneaking the software into that company. He got caught,
Wah,
and
wah,
he got,
wah.
yep, 8 years of federal jail time, which is
Oh,
serious business.
yeah, yeah, yeah.
Straight out of Office Space.
Oh man. Okay. Yeah, we'll just move on. So don't steal code, ladies and gentlemen.
Yeah,
Bad
yeah. So this
idea.
is interesting, right? For several reasons. One, it's he didn't actually make any money off of it or steal any money. So in that respect, it seems like 8 years is extremely serious. But this goes to show that people in companies take this stuff extremely seriously, and it's your responsibility, as a software engineer to be ethical in these types and not try and pull these types of shenanigans.
Yeah, definitely. I mean, I guess it's good that it shows that, he didn't get off easy for doing something that's, stealing essentially the livelihood of the business. Not that I'm a big defender of the banks, but still.
Yeah, yeah, exactly.
It's wrong. Yeah, definitely.
Yeah, I mean, you can definitely get hit hard. So
Yeah.
if anyone out there works for Goldman Sachs and is thinking of trying to pull a stunt like this dude got 8 years in federal penitentiary. So
If that's the average salary, $400,000 a year at Goldman Sachs, please donate to our show.
yeah, that's
Programmingthrowdown at
right.
gmail.com.
Yeah, we'll set up a PayPal account just for you, Mr. Goldman Sachs employee.
Yeah. So,
Oh man.
no, those guys they work crazy hours. So, and they've gone through a tough spat. So don't envy them.
Yeah. No, this is hard times for everybody, and I'm sure those people are no exception.
Right.
So I have another news article. Do you have one now, or do you want to go
No,
back and
I
forth
think we're done
or?
with mine.
Okay, so this is kind of interesting. This was from Newswise, and this guy wants to start investigating. It's a professor, young professor, and he wants to investigate green computing or energy efficient computing. And so, programming languages, they usually serve, one of several purposes. One is, let's say efficiency, like in the case of C or C++, where you really need to push data through or do some, real expensive computation. Or they work on they try and maximize productivity. So Python, one of the languages that we'll be talking about later today, is sort of focused on productivity and trying to save your time and be programmer efficient, if you will. No one really that I know of has up until now looked into this energy efficient computing. So this is really quite interesting. And as we're moving to mobile devices, and in general, as being green is kind of in right now, this has win written all over it from a professor standpoint. So
Yeah.
he got some really nice grant money, and I thought this was pretty cool stuff. I like to see kind of what comes out of it.
That's interesting. So, in compiler optimization, you can compile for code size, compile for speed, compile for memory footprint. Now, I guess you're going to have a compile for energy.
Yeah, I mean, what does
That'd be
that
cool.
mean? I mean, I guess in a superficial sense, you try to limit the number of instructions, But then even then, I mean, you might try to get more cache hits. Maybe that saves energy. I'm not really even sure.
Those seem things that you would do already just to improve performance. I
Yeah,
guess
it's
if you're
true.
willing to sacrifice, this would be a hard thing to do. But if you're willing to sacrifice, kind of the deterministic execution speed, you could, do things like pausing and collecting up all the disk accesses or RAM accessing at one time and kind of do them all in a bundle, even if it means waiting to do it. But it seems like they kind of already try to do that.
Yeah, it's hard to think of things that are energy efficient but that don't increase productivity. Trying to think of something off the top of my head.
I, I mean, I've heard before, this is at a much, much lower level, but the whole idea, which is extremely fascinating, and if you want a time sink of black hole of your effort for the next couple days, look into reversible computing. So
Really?
the idea
I've
of
never even heard
so
of that.
there's this whole, and I'll quickly show how much I don't know to anybody listening who knows anything about this field. But I guess it comes down to kind of information theory that one of the reasons why we're hitting an upper limit on the density of transistors and doing stuff in our chips and is that when you do an operation, so like an and, right? So you do one and one is one and zero is zero, but zero and one is also zero. So you're losing some information there. That operation's not reversible. Neither is an or. Most of the operations are not reversible. A not is reversible, right? Because you just not it back, so that you don't actually lose any information. So the idea is that when you destroy information, that is kind of somehow related to energy. And so when you lose information, kind of destroy it, you're going to expend energy. That information has to go somewhere and it dissipates into heat or whatever. And so the idea with reversible computing is to say if you can kind of keep track of all these sets of operations and be able to at some level undo it, and you kind of accumulate this log of everything, that you'll run more efficient. And then at some point you could kind of choose to get rid of all the information, all the bits you don't need, and kind of exude power at that point on your terms and your choosing. It gets very weird, and the information theory gets crazy. It gets tied in with like black
I think you just
holes.
blew my head.
Black
Blew my
holes
mind.
destroyed. Do they destroy information or not? Yeah. And then there's the Maxwell's daemon. Oh,
I guess there's like several. So you're saying there's a bunch of instructions that don't destroy information, and those cost less energy or cost no energy
so
or
I,
something.
I don't. The way I've seen it explained is with billiard balls. So you can make an AND gate out of billiard balls, but you can also make that kind of you end up with. So if you do an AND, you end up with the output of the and also like another bit that represents to distinguish between the 0 1 1 0 case. So you end up with this extra bit of information
Oh, I
that kind of
see.
allows you to know how you got to having the zero, whether it was from two zeros, a 0 1 or a 1 0. And so you kind of record, or maybe you end up with 3 bits. Somehow you end up tagging along that extra information that allows you to reverse the computation. Anyway, like I said, it's a time sink. I don't really understand it, and I probably just made a bunch of people who know what they're talking about realize how stupid I am, but that's okay.
No, I think you just made them angry, which is
Okay.
that's one of the goals. If we
Yes.
can't teach you something, we at least want to piss you off.
Write to us and tell us how we messed it up, and maybe we'll get you on the
Yeah, that's
show and
right.
have you explain it to us for reals.
Yeah, that's right. If you hate us, give us 5 stars. That's the worst rating you can give us on iTunes.
So,
This is so I think also not just extending, he's in this particular article they're talking about making energy Java, which is an extension of Java that would somehow be more energy efficient, but also more different languages I think would be inherently more energy efficient, provided that you're running on a multi-core system. And so for example, a GPU, per watt or whatever can deliver a lot more computation than a CPU, but it has limitations because for example, all the cores in a GPU have to execute the same instruction at the
mm-hmm.
same time. So if you have a programming language or a construct that sort of helps guide you to work within those limitations, then maybe something that is like very highly multi-threaded could allow you to save energy, because that's really where a lot of the energy is wasted and is in the bottleneck, where you have this huge bank of memory but then only one small tiny sliver of it can be used at one time on a single core processor.
I guess that's why we have research, right? So if we knew the answer, we wouldn't need to research it.
Yeah, exactly. Yeah. So this is a news article on Brainiac, and it was on the origins of Oregon Trail. And I don't know if you had this or if this was just something we had in Canada, but in Canada we had these Apple IIe's. There was like a computer, I don't know, I guess using period in school, and we'd jump on these Apple IIe's and play Oregon Trail and
Mm-hmm.
Odell Lake. And did you guys do that?
Yeah, at some extent. Yeah, we did.
Oh man, yeah. So it's just good memories.
Like,
And
where in the world is Carmen San Diego?
oh yeah, that one was fantastic. And this article is talking about just Oregon Trail, where it came from. It's actually programmed and designed by some teachers who just happen to be really geeky and into coding. And they were inspired by Choose Your Own Adventure books. And it was really, the thing about Oregon Trail is it's a complete simulation. I mean, it's very egocentric. It's not like other wagons are passing you by or anything like that. But in the sense that you're traveling along this trail and you're having to deal with hunting for food, and the environment can influence the hunting grounds and things like that. It's almost a complete simulation, which makes it just very interesting that something this old, that old, could be that powerful.
Yeah, a lot of people seem to remember that. Most people our age kind of remember playing it. You've got dysentery.
Yeah, that's right. It's funny. In fact, the news article has a caption or has a figure, and yeah, the figure clearly states that Nicole has dysentery. And you can go on virtualapple.org. I don't know if you've ever been on this
No.
site. Oh yeah, it's great. www.virtualapple.org, and it has a number of Apple IIe games. I'm not sure. It says that it's copyrighted, all rights reserved, et cetera, et cetera. So I'm not sure what the legality of it is. But it seems legitimate. It doesn't seem like it's that they're doing anything illegal. Maybe they have permissions. I'm not sure. But Oregon
Use at
Trail is
your
on
own
there.
risk.
Yeah, that's right. Oregon Trail is on there. Odell Lake is on there, and it's actually a Java applet. So someone built an Apple IIe emulator in Java, and runs right there in the browser. It actually might even be a browser plugin.
Interesting.
So
Well, I don't want to open this
yeah,
up right now. I'll end up
you'll
messing
end
up
up
our
on the
Skype.
trail.
I'll end up messing up our Skype connection and/or man, get that deer! Get the deer! Get the deer!
Yeah, that's
Ah,
right.
I should have fjorded the river.
Oh yeah, remember there was one where yeah, I
Oh, I
mean
guess it's
I
just
had no
forded the river.
idea.
Never mind. Okay, sorry. Go ahead.
Yeah, I mean at 9 years old, we had no idea. So there's this river. It was like I don't know, Swanee River. I don't remember, but it was something like 20 feet deep, and I was like, oh yeah, just ford it, just walk across it, and then you lose everything.
You have
You end
been
up
washed away.
you end up crying at recess. Yeah.
Oh, okay. We're nerds. All right. So my tool of the day is a cool distributed version control system. So, in the vein of Git, Mercurial, what are the other big ones? There's a couple other ones. But,
A subversion.
well, Subversion's not distributed, though.
Oh, that's right. Right.
So distributed ones. But this one's interesting. So the thing I kind of like, and I've been trying to do better about, it's not really the new year anymore, but my semi New Year's resolution for the last couple of years has been to do better about version control at home / for personal stuff. And one of the nice things, Subversion has some tools will let you do that, but it's not really set up to do that. The nice thing about the distributed stuff is that that's kind of how it always is you can just have a repository on your local machine, and then at some point you kind of merge repositories with other people who could have previously had a version from yours, and they kind of split up and move throughout. There isn't a one central repository that's the repository everybody refers to. So that kind of confuses people, makes it a little bit hard. And I'm not an expert by any means on version control, much less distributed version control. But Fossil's nice because it's a single executable that you put in your path, and you're able to. So I use it on Windows, and you're able to like check stuff in and out, and there isn't a complicated system behind it. I've used Mercurial before and Git to some extent, and they're nice, but they're kind of tangled up in. They do a lot more. This I guess it probably does a lot, but it's really simple. Just one executable, really basic, and I've been using it to do version control on my local computer for stuff that I should have been always using stuff for and just haven't really been doing.
This looks nice. I have had so much grief with Git using GitHub. I've gotten to the point now where I use the Tortoise Git to
Mm-hmm.
do a Git commit because I like that interface better and it integrates with Explorer and all that good stuff. But then I have to use the Git GUI, which is a separate program that comes with Git, to do the push. It has something to do with like I could never get the SSH key working right
Mm.
in Tortoise Git. And I've just it seems like I just have so much trouble with Git. So this looks awesome. I'm definitely gonna check this one out.
Yeah, so like I said, I'm not an expert, but I liked it, and it has the ability to set up a server within it. So like, I could put it open, and then somebody else on my network could, download my repository or whatever and clone it. So it's nice. I like it. It's worth looking into.
So what would you say is the difference between a distributed version control system and just a regular version control system?
I'm gonna really get people mad at me
Quiz
now.
mode.
I'm really gonna get people mad at me because I'm ashamed to say I'm not very polished on my knowledge of version control. But
Oh, me neither.
so the way I understand it is, Subversion, CVS, they kind of work on the idea of a central repository. There's one location that is the master, and you, depending on your workflow and the exact nature of the system, you check out files or, get a copy of the repository, work on it your own, and then you submit back to that central repository. So you can like lock files there, work on them and then resubmit them back with changes. And then other people go check against that, can pull changes, do their updates, fix stuff, whatever. The difference with a distributed version control system is that certain operations which are complicated to do in one of these others are become very easy to do, like branches. Branches are really easy to do. And having
Oh, I see.
multiple versions of the code existing at one time, like 8 different kind of parallel paths going at one time, isn't really a big issue. And the way that you do, and even on your computer having multiple versions is easy because there is no central repository. You can have one, right? Like you and I could say, oh, we're gonna host on GitHub. That's our official repository. But in reality, it's just another version of the repository, and everybody's is just as important or authoritative as anybody else's. And so, for instance, I could push to you my changes. You could make them in your repository, and then you could push them up to the GitHub server. I don't have to push
Oh,
them
I
up to the
see.
GitHub server. You get them, bring them back down. We can like share with each other and commingle those because there is no one branch that everybody has to come down from.
Oh, interesting. Yeah, I mean, in Subversion, if you were to create a new branch, you would have to go to the master server and say, hey, I want you to split, and make a new branch for me. Whereas it sounds like with this system, you're making your own branch and it has nothing, you don't need the server's permission. And the server doesn't even know you have your own branch per
Right,
se.
right. And I can make multiple revisions, multiple check-ins against myself. Forward those to you. You merge some changes, do additional, and then you merge back to the quote unquote, central, authoritative whatever base. And then if you actually look at it's kind of cool when you look at the, version history, you see all these merges and splits, and you can do things that would just cause a nightmare under most repositories.
Oh, nice. That's good stuff. I'm definitely going to check out this fossil. That's awesome.
So,
So yeah, I guess
what is your
my
tool
tool
of
of
the
the
week?
day, my tool of the day, or I guess of the bye week, isn't
By
isn't quite as
winning.
cool.
Oh, sorry.
Oh my
Sorry.
gosh.
Sorry. Oh.
My tool doesn't have fossils or tiger blood, sadly. But it is actually extremely useful. I've been using it for a while now, and I think it's fantastic. It's called Unison, and specifically I'm talking about the Unison file synchronizer. And so what this does is you give it two directories, and they could either be local directories or one can be an FTP, one could be an SSH, an SSH location on a remote server, and it essentially compares the two directories recursively, and then gives you a list of changes. And it can do this in a variety of different ways. It can compare the dates. It can actually compare the content. And in the end, it presents you with this list. If one of the files is newer on one of the directories than the other, it will automatically suggest to, move the newer file over to the older one, and vice
Hmm.
versa. Otherwise, if it can't figure it out, either because it doesn't have access to one of the dates or gets confused or something like that, or if both files have been modified since the last time you ran Unison, then it will put up a little question mark, and you can make the call on, do you want to diff these two files manually and merge them together that way, or do you want to just pick one file or the other?
Nice.
In general, it's great for synchronizing your USB stick. So if you have a bunch of docs or a bunch of files on your USB stick, you don't want to run the risk of losing the USB stick and losing all of that data permanently.
Right.
So you can run this Unison program and put your USB stick and then put a directory on your hard drive, and it will sort of keep everything in sync.
Very cool, very cool. I've actually been looking for something like this, not quite like this. This is interesting that ours are almost tied together, almost like version control for your USB stick. But that's funny. They
Yeah.
almost made the same thing. But so I don't know if you used Dropbox before, but Dropbox, uses their server in the cloud to kind of take data from a folder, store it there, and also push it out to other folders, kind of keeping them all linked up together.
Right.
And I've been looking for a version that I could host like in my home network and do the same thing across all my computers. So like keep all of my documents synced up
interesting.
together. And there's you can do it with Dropbox, like that'll work fine, but there's a limit to their free size, and you have to pay if you want more. And I kind of just want something that I don't care about how much data it's syncing across. And I found one, but they're not in release yet, and I haven't tried it yet. But it's called Sparkle Share. And that's kind of that. It doesn't help you with like USB sticks like you're talking about, but keeping, multiple computers in your household synced. Like I'm constantly moving from my desktop to my laptop, and I would love to be able to just know that all the files are on both and not have to worry about, oh, that's on my laptop, I need it on my desktop. Let me email it to myself or put it in a USB stick or whatever that's.
Yeah, this is interesting. This is good stuff.
So
Yeah, it seems like, it shouldn't be that hard. Like they have to kind of hook into the OS, but whenever they see that, a certain file has changed in a directory that they're monitoring, they can, go and propagate, and give that file to everybody else. It's one of those apps that seems kind of straightforward, but then the devil's probably in the details there,
Definitely.
especially if you want to make it run on Mac and Windows and
reliably.
Samba and reliably. And it has to recover. Like if your machine, if one of the machines goes down, when it comes back up, it'll have to try to, get him back in sync and all that.
Right. Not trivial, but if somebody could do it in an open source package, that'd be awesome.
Yeah, definitely.
So, well, is it time for the throwdown of Python?
I think so. Let's throw it down. So I guess I'll cover this. So Python is an interpreted language. It is semi-compiled, which means that there is a Python virtual machine similar to Java, and you can compile Python files into bytecode for that virtual machine. So in that sense, it can take advantage of compiling, but overall it's generally interpreted language. And the goal of Python is productivity. So Python boasts, a 4x increase in productivity. So in other words, if it takes you 4 weeks to write some app in C or C++, then, in theory, you can write it in a week in Python.
I assume that would be an experienced Python person could write it in a week in Python.
Yeah, oh yeah.
This doesn't have magical powers, does it?
I think it does. I think Genie's come out and actually plug in, little Bluetooth USB keyboards and just write alongside of you as you're writing.
What? Where has this been all my life?
I know, it's the Genies. They're there. I think that, yeah, you're right. You have to be experienced in Python. And it's one of those languages that does come with a learning curve. One of the big things about a lot of these high-level languages, like Python, is that it gives you a lot of flexibility. But because it does that, you can kind of hang yourself with all the rope that it gives you. And so that's why, having a strong foundation in one of the imperative languages kind of will allow you to sort of remain grounded in your architecture, even with all of the flexibility that Python gives you.
So why is it named Python?
Oh, that's a great question. Do you know the answer to that, or are you just quizzing me?
It's a Monty Python reference.
No way.
Yep.
Is that? Oh wow.
Yeah.
I have to look that up.
No, definitely. So I figure any programming languages that uses Monty Python references sprinkled throughout has to be good.
That's right.
Or at least British. I don't know.
Oh, yep, you're right.
Oh, what? Oh, hang on. Theme music? Theme music? Where is it?
You're like, you're that's gonna get saved. Like that's gonna be dubbed out now. Whenever we have an argument, you're gonna bring that back.
Yeah. Remember
Um,
about the Python.
Interesting. So, yeah, so let's talk a little bit about more about Python. It's garbage collected, similarly to Java. So, in other words, you don't have to, as you might remember from our C podcast a couple of weeks ago. In this case, you don't have to, tell the system when to allocate in free memory. You just say, hey, I have this list of data, I have this dictionary, and the dictionary of it's a dictionary of phone numbers, and I want the phone number of Joe to be 999,999, and it automatically decides I'm going to create a dictionary, I'm going to allocate memory for that dictionary. There's a new entry, maybe I have to increase the size of the dictionary to handle the new entry. It does all of that. So you're completely oblivious to the memory manager.
Sounds powerful and dangerous.
Yeah, I mean, definitely. If you're working on a system that doesn't have a lot of memory, such as, an embedded device, you have to watch out for, running out of memory. And in fact, with Python, this is especially an issue because it has a virtual machine. I believe the virtual machine has a memory limit. So, in the case of C++, you can, for the most part, allocate memory and just keep on going, keep on allocating memory. And it'll eventually start, putting memory, what's called virtual memory. It'll start creating memory regions on your hard drive, but it'll essentially give you the freedom to do whatever you want. In the case of Python, there's a hard limit in the virtual machine, and if you try and allocate, I don't know, 27 gigs of memory, it's just going to throw up. It's going to cause an error in the virtual machine.
So I see this phrase batteries included. What does that mean?
Yeah, so so Python comes with the Python standard library, and the Python standard library is actually just extremely massive. So yeah, one module in the library is pickle, which I'll talk about a little later for doing serialization. It has zlib. So if you've ever had a .tar.gz file, if you've ever downloaded one of those off the internet, that's using zlib, and Python supports that natively. So just let's look at that for example. Let's say you wanted to write a C program that opened a .tar.gz file, or let's say you wanted to write a C program that created one of those. You would have to go grab the zlib library, compile it along with your code, read up on the API and work your way through that. With Python, all that stuff's included. So you don't have to worry about building zlib and what sort of, compile parameters you need to give it and things like that. All that stuff's in there. It has, comma separated values for writing stuff that could be read by Excel. It's got hashing, just tons JSON encoding and decoding, email handling. The Python standard library has a HTTP web server built into it. So you can host your own website using just Python.
So you can get hacked without even needing an extra library. No, I'm just teasing.
That's right. You can have your users' email addresses leaked like TripAdvisor did earlier today, without anything but Python.
So that's cool. That's cool. Now, the fact that it has all these libraries, is there good documentation for those?
Yeah, so there's docs.python.org, which is Python's own documentation system, and that is extremely comprehensive. And I think you've also found a couple of websites to kind of learn Python as well, right, Patrick?
Yeah, so under the kind of one of our charter goals here is that help people see the uses of other languages. So for instance, we talk about Python being helping you be more productive potentially, and so as part of that you got to learn those languages so that you can exploit the benefits to the fullest. So talk about a little bit about our experiences, if we have any, with learning the language. And one interesting thing, if you're listening to the show and you don't yet know any programming languages, I think a lot of people consider Python a good first one to learn. What do you think, Jason?
Yeah, definitely. I think that I think Python was one of the goals of Python was to sort of be simple to use and to understand, and it seemed like there was almost an educational focus to Python, and because of that, I think that. Python would definitely be a great starter language. One of the things that you really have to watch out for in languages like C and C++ are dealing with these really high level structures and manipulating structures and memory and reading and writing structures to files can be challenging. And so Python obfuscates all of that from you. I mean, you don't really have to deal with a lot of that low level stuff, and you can get right to doing what you want. I mean, typically, what people want to learn programming so that they can do something, so that they can accomplish something, whether they want to write their own little web calendar to keep themselves focused, or whether they want to just kind of make a game or something to entertain themselves and their friends. And you don't want to get bogged down in a lot of the details, especially as a beginning programmer or working on a project by yourself. And so Python really does a lot of that heavy lifting for you, at the expense of being slower than one of the more low-level languages.
Yeah, definitely. And so my first kind of learning link that I had here is something I ran across, and of course, already having a fair amount of experience with programming, this was not that helpful to me, but it was really interesting. And I believe the guy who started this, but it's kind of a community effort now. I think his name's Zed Shaw maybe. And he has Learn Python the Hard Way. And we'll include the link in the show notes, but it's learnpythonthehardway.org. And it's kind of interesting. It's a book, and it kind of goes through and says, look, this is going to be confusing. When you learn these programs, it's not going to be easy and straightforward. So he kind of starts out by going through stuff that, would have kind of been nice. I remember learning, programming kind of on my own before going to, school for it or having a class on it. And he kind of takes you through what I think a lot of people end up doing, which is, type this code in. You're going to make mistakes, but type it in. Just copy this code into a thing. Don't copy and paste it. Type it in, and you're going to begin to kind of understand, become familiar, and intuit what the programs are doing. And then also that'll kind of, since you type it in, you'll kind of lead you to experiment and start trying little things and seeing how it changes or reacts or what breaks. And kind of approaching it from that way, which is an interesting way. I hadn't really, it's a refreshing take on how to learn programming.
Yeah, that sounds awesome. I'm definitely gonna have to give that a shot.
So the other resource I had here is PyCon, which is the big Python conference. I think just recently the 2011 PyCon happened. I think it was in Atlanta. Is that right?
Yeah, that's right. And the next one, 2012, is going to be in Santa Clara, California, which is right next to Google, right next to Mountain View.
Now actually that's a good point. Google uses Python a lot, right?
Yeah, so Google has employed the creator of Python, Guido van Rossum. I believe he worked at a number of large, well-known companies, but right now he's been employed by Google, and Google is definitely taking Python seriously. They're one of only two diamond level sponsors of PyCon 2011, and so yeah, they're definitely
Who's the other
interested
one?
in it. The other one is QNX.
Oh,
I think that's
interesting.
embedded, right? Embedded
RTOS, isn't it?
Yeah, that's right. Why don't you explain RTOS for a bit? I know it's kind of a digression.
That's totally not related to Python, really. But
maybe here I'll do it really quick.
Okay.
Basically, most people are familiar with OSs, operating systems like Windows, Linux, OS X, etc. RTOS stands for Real-Time Operating System. And to make a long story short, basically, they operate within certain limitations. So in the case of Windows, again, going back to this memory thing that I talked about earlier, if you want to allocate, a gig of RAM, and you don't have a gig of RAM on your machine, it'll go into virtual memory. So it'll make a space on your hard drive and treat that space as memory. So real-time operating system has certain limitations, like you cannot do something like that because it would take away from the real-time nature. It just takes too long to do something like that. And so there's many other, it gets complicated, but the basic gist of it is that they're interested in high performance, low power operating systems.
Interesting.
So yeah, actually that gets to an interesting point, which is another lesson of this is it's true that Python has a reputation well suited for being slow. But again, it comes down to how the language is used and a lot of the algorithms that are going into the language. So in other words, you can write some code in Python, someone else who can write the same code in C, and it could be 100 times slower. just because of the way that you designed your algorithm. Let's say they're constantly creating and deleting arrays, and in your case, you're able to use just one single array. So, a lot of the speed issues can be solved algorithmically or using, being efficient in the way that you allocate and deallocate memory. And, I wouldn't worry too much about Python being, slower than other languages.
Yeah, I mean, especially for prototyping or even in full up production time, I mean, using it as kind of like the scripting aspect. And we haven't talked about this yet, but Python integrates really well with C code.
Yep.
So you can, of course, one of the good paradigms to go by in your programming is don't optimize too early. Don't worry about getting your code to run fast. Worry about getting it to run first.
Yeah, Donald Knuth, right? The one of the founders of computer science said premature optimization is the root of all evil. So,
Ah,
yeah, definitely. And I think that, to sort of extrapolate on that point, the biggest thing I see with like a lot of kind of new or green engineers is that they'll write some code, it will be slow, and they'll sort of look at things which are somewhat myopic, like maybe if I do a compiler optimization or if I change languages but really, there's something fundamentally slow in the algorithm or in the architecture that can give you just a gigantic speed up.
definitely. And being aware of how the computer operates, which we haven't talked about here yet, but I mean, understanding at a fundamental level why your computer does what it does, how it ticks,
Yeah.
even down to, not that you have to go that far, but we were talking about AND gates and OR gates a few minutes ago. But I mean, understanding a computer at that level helps you write code that uses a computer in the best way possible.
Yeah, definitely.
Okay,
So do you want to talk about, oh, go
well,
ahead.
sorry. So we got in a little bit of a rabbit trail, but so
Yeah.
PyCon, the Python conference, just finished
Okay.
up in Atlanta, and they actually, and I don't know if they posted all of them, but they have a lot of videos, recordings of their sessions posted online. And we'll post a link, but it's pycon.blip.tv. And I've been watching a few of them, and they're actually pretty good quality and really interesting. So if you've always wanted to go to a conference or never thought about going into a conference, and you look at the topic list and see some interesting things there, go check it out and watch some videos. Most of them are 30 minutes to an hour in length, and talk about everything from everyday parts of Python and panels on what's the best IDE to use for Python, all the way to like really specific optimization kind of libraries and techniques.
Yeah, this gets to kind of a little digression, but I think an interesting point, which is, many of you out there work for, tech companies or maybe IT companies, but work, sort of in the software engineering industry. And, you should definitely, ask your management if they can send you to PyCon or one of these conferences. That's sort of a win-win. I mean, most of the time, most companies have a budget for training, and very often people don't take advantage of the budget, and that money gets wasted. By going to one of these trainings, you can learn a lot about Python or something else, and you also become more valuable. I mean, your employer knows that you've went and gained this skill set, or you've went and gained some connections with the top people in a certain field or in a certain topic, and that can really help you along further down the road. It's an investment.
Yeah, hopefully people's jobs are amenable to those kinds of things.
Yeah, yeah,
It never hurts
definitely.
to ask, right? What are they going to do? Tell you no?
Yeah, I mean, worst case, they tell you no. At least, even by asking, you can, remind them that you're inquisitive. I think that it's useful.
Yeah, definitely. And I think we could all stand to be told no a little more often.
Oh yeah, that's right. What is it you're trying to? I think your metric was to get told no once a day, right?
Yeah, so this was an interesting thing on Hacker News a while ago. I haven't seen anything about it recently. And I don't remember exactly how they phrased it, but it boiled down to this guy came out and said, we assume too much in our lives about restrictions and barriers placed on us. And so if you just make it a goal every day to get told no on something, anything, not a silly thing, but an actual something, get told for real no, that you will learn quickly that we're trained from very young age not to say no to people. So for instance, he I think one of his examples was he was in some big city and took a cab ride and said, "Oh, I forgot my wallet," or was getting in the cab and said, "Oh, I forgot my wallet. Do you mind taking me, for free?" And the guy's like, "Oh, okay." Just kind of like, didn't want to tell him no. Or he would wander around areas that looked restricted and people would come up to him and say, "What are you doing here?" He's like, "Oh, I don't know. I'm just wandering around." And he's like, "Do I need to leave?" And they're like, kind of, but they had a really hard time telling him, like, "Yes, you need to leave." So
This is amazing.
yeah, so his thing is, go to your boss and ask. You say, "Well, no, I don't want to be told no. They're going to think I ask too much." Well, go ask, because you don't know. Like Jason pointed out, they probably have a budget for it. And if that budget's not getting used, it'll disappear. So they may, in fact, be glad to send you to the conference.
Yeah, definitely. Okay, let's talk a little bit about virtual machines.
Yes.
Python is kind of interesting in that it actually has several different virtual machines, and they all have kind of really unique purposes. So the first and the most common is C Python, and this is
Well, hang
oh,
on.
go ahead.
So what is a virtual machine?
Oh yeah, this is a good question. So a virtual machine, and I'm probably going to butcher this because I'm not going to
It's okay. I
Wikipedia
did
or
it twice
anything.
already this time. So it's your turn to sit into the hot seat for a minute.
Oh man, I'm in the hot, I'm sweating. So a virtual machine is basically a software implementation of, the fundamental components of a computer. And what that means is essentially a memory space, so a block from which you can, allocate chunks of memory, a processor which you can, pass instructions to, and a set of registers which you can pass sort of as arguments these instructions to do computation. So let's talk a little bit about an actual machine, about a computer. Basically, the way the computer works is you have a bank of memory, and we'll just say the memory is indexed by a number. So you can get memory location 0 through 10,000, let's say. And if you want the number that's in memory location 650, you can go and ask and query the memory for that information. Once you get data from memory, it goes into registers, which are locations on the processor itself, on the chip, that hold information. Once you've sort of loaded the registers with information, you can run computations on them. So you can load two registers and then add them together and put the sum of those registers into a third register. That would be an add instruction. The instructions can be simple, like that add. They can also be very complicated. So on the VAX machine, there was actually a hardware instruction that would sort a list. So you gave it 16 registers as 16 operators, or 16 parameters, and you gave it the sort instruction. And in hardware, there were physical, copper traces that did the sort algorithm for up to 16 elements. So that's the way a real machine works. In the case of a virtual machine, everything is in software. So in other words, the implementation of your instructions, if you, let's say you have a sort instruction, the sort is actually done in software. And the sort is actually done by, in this case, like using some for loops or whatever, which execute on the actual machine. Your registers are also just locations in memory on the actual machine. So there's no chip in this case because it's virtual. And your memory corresponds to memory in the actual machine. So that's not too different. So the interesting thing about a virtual machine is that for one thing, you can give it any instruction you want. You can make your own instructions because you're not actually doing anything in hardware. You're just composing new instructions from the instructions that already exist on your machine. You can also you have more error checking. So if you, let's say, do a divide by zero in hardware, that's going to produce some answer. I mean, the electricity is going to flow through those wires and something's going to happen. You're going to get a number. So it'll probably
Actually, I
be,
think sometimes you get an interrupt,
oh, you can get
a
interrupt
divide
for
by zero interrupt.
usually you get, on most
Maybe. I
OSs,
don't
you
know.
get a
Keep going.
nan. Yeah, so usually you'll get a nan. There's some
If you're in
specific
floating point,
number.
yeah.
Oh, right, that's right. So there's some specific number that corresponds to not a number, and you'll get that number. On the virtual machine, if you do, a floating point divide by zero, or an integer divide by zero, you can crash the virtual machine. But because the virtual machine is all done in software, you're not actually crashing something, on the hardware level. And so it's much easier to debug. One of the bad things about a virtual machine is that it's inherently slower. So if you call add, well, add's kind of a bad example because it just calls the machine add. But let's say there's some instruction called
Foo.
yeah, there's some instruction foo, which actually corresponds to doing 10 adds or something like that. Then, that instruction is actually going to be quite slow because it's going to, actually turn into many different instructions.
So,
So, oh,
oh,
go
sorry.
ahead.
No, no, go.
Yeah, so basically a virtual machine sort of gives you a lot of control. You can see, exactly what's going on with the system. Since it's all in software, you can take a snapshot. So you can save the state of the virtual machine and then go back. So you can reload your crash over and over again and see exactly how it happened.
Interesting. It also provides portability, so running across different actual processors, you can provide the same interface to your program.
Yeah, definitely. So let's say, for one example, if your processor has SSE on it, you might have access to SSE hardware instructions that, someone else doesn't have access to. But in the case of the virtual machine, all of your instructions are in software. So as long as you can compile the virtual machine for your particular computer, you know that you have access to every single instruction.
And interesting things, which are another kind of gotcha, but the virtual machine on the computer with SSE could have SSE acceleration, but then you could run on another computer and assume that that's there because those instructions are still there, but that acceleration can't happen because there isn't a
Right.
hardware, so that has to be done in software.
Right, that's right. Yeah, so that's actually interesting. The virtual machine can run faster or slower depending on the specs of your actual machine and what instructions are actually there.
So what's the difference between a virtual machine and an emulator?
Oh, interesting. So that's a good question. Mm,
Okay, I'll give my opinion,
okay, yeah,
and then
you go
then you could
first.
tell me if I'm right or wrong. But I mean,
Okay.
so an emulator, which we haven't talked about, is kind of taking a real world, and these are generalizations, but taking a real world device. And so we were talking about the Apple emulator online before the Apple IIe emulator. So taking a real device and creating a program that runs on other hardware typically. So, for instance, in this case, a Windows OS running on an Intel processor and simulating every hardware aspect of the Apple IIe that matters, so that you could take a program that was written for an Apple IIe and without changing anything in that program, run it through your emulator, and it would know no difference, and it would behave the same, and the user could interact with it if it's a user interacting kind of machine. Versus a virtual machine can implement essentially a hypothetical machine, a machine that doesn't exist in the real world. So Python doesn't implement a virtual machine that is a facsimile of another machine. It could have 1024 registers where no real machine's going to have that many registers. It could have,
Right.
in theory, a infinite stack that no hardware could actually have. It can do stuff that isn't possible in real hardware, or even has just never existed in real hardware, and it's not bound to trying to emulate some other kind of hardware, just providing a consistent interface to programs that are written for it.
Yeah, I think that makes sense. I think that, the biggest point there is the fact that, like you said, the emulator is actually emulating another system, whereas, a virtual machine can be completely virtual.
But I guess
There are so,
fundamentally they're the same, though. So
yeah, I think a lot of it is connotative. Emulators are typically, where you're going and trying to emulate a machine, a specific piece of hardware like a Nintendo or something. Whereas a virtual machine is often referred to, emulating an operating system, like running, Linux inside of Windows using VMware, something like that.
yeah.
Or in this case, running a Python machine inside of a Windows or a C-based machine. Yeah, so let's talk a little bit about the different Python virtual machines and
Okay.
why
Yep.
they're
Sorry, got
important.
on a little side talk there,
No, I think it's
but
good. It's good. So there's C Python, which is the original Python virtual machine, and it's, as the name suggests, coded in C. It's compiled for whatever actual machine you're running it on. So if you're on Linux, you're using Python virtual machine that was compiled for Linux, and there's a bunch of compile defines to try to, use the same code base on many different machines. There's also stackless Python, and stackless Python is actually quite interesting. It gives some extensions to Python that make it more multi-core and multi-processor friendly. And
Hmm.
have you ever used stackless Python?
I have not. It has, yeah, it does a lot more for multi-processing type stuff or parallel processing, right?
Yeah, one interesting thing about stackless Python is it's used by Eve Online, which is the which boasts the largest user base, largest single online server user base of any multi-user environment. So I believe there's tens of thousands of people on a single bank of servers that can all potentially interact with each other simultaneously using Eve Online. So, World of Warcraft has millions and millions of users, but it's split up into several what's called shards. Actually, sorry, it's split up into several servers, and then each server is split up into shards. So what that means is, let's say, I might be playing on server X, and Patrick is playing World of Warcraft on server Y. We have no way of really, interacting with each other. We're in completely different, universes, and so they're completely disjoint. So you can think of each of those as a completely different game. Then on top of that, different areas of the world of a single server are sharded. So if I'm in one area and Patrick's in another area of the world, we're on different physical servers. So in contrast with EVE Online, everyone can be in exactly the same location at one time. All of the users in the entire game. There isn't multiple servers, and so they boast that they're able to do this because of stackless Python.
So they can have gigantic flash mobs.
Yeah, that's right. That's right. And there's crazy news stories on the New York Times and other papers on just crazy things that have happened. I think one time, one faction or one I think it's called a corporation went to war on another corporation, and over the span of a few weeks, something like $10,000 or $20,000 of real money, because apparently there's a conversion between real money and EVE Online money. It's like $20,000 was lost in this battle. It's just insane the kind of the magnitude.
Hmm.
And so yeah, stackless Python works basically by enhancing Python using something called tasklets, which are actually I think in Python they're not called tasklets. I think they're called micro threads. But basically, just to explain it briefly, variables and data. When you're doing programming, certain you might have access to a certain set of data, and you're doing computation, and you might say, okay, I want to sort both of these arrays. There's just these very large arrays, and I need to sort both of them. What I'm going to do is create two threads. And in the first thread, I'm going to sort the first array, and in the second thread, I'll sort the second array. And if you have a multi-core CPU, it can do both of those things simultaneously, and that gives you, a 2x speedup in time. So stackless Python has a very high affinity to being able to create threads. Typically, when you create another thread, you have to sort of tell it what variables are yours, what variables are mine, and you have to create what's called a frame for that thread. With stackless Python, you can create micro threads which don't have a frame and don't have a context. And because of that, it runs extremely fast. So if you need to create a lot of threads, you can do so very efficiently. So to go back to EVE Online, they might have a thread for every player that's constantly updating the player statistics and things like that. And that architecture is what allows them to scale to those levels.
So we got CPython, stackless Python. Any others?
Yeah, so there's PyPy, which is a Python virtual machine written in Python. And I always thought that this was sort of an educational thing, something that Python developers can use to learn more about the language. But I'm learning more now that PyPy actually runs Python code faster than CPython. And it gets really hairy as to why this is, but basically it boils down to again, coming down to these frames. So in C Python, every time you enter a new function, it has to create a new frame. So if you create a new variable inside of a function, it has to know that that variable is with that function. And when you return out of the function, that variable needs to be destroyed. So the set of all variables inside of a function is called a frame.
Local
And
variables.
yeah, local variables, that's right. So CPython, I guess the frames require a lot of overhead, and as you're calling functions and returning out of functions, you're wasting a lot of time. And PyPy somehow gets around this by using something called virtualizables. So yeah, I still have more to learn there, but it is another Python virtual machine to consider if you're developing in Python and performance is important.
They also do a number of interesting tricks, which probably we're running a little long in time tonight, so we won't necessarily talk about. But just-in-time compilation and stuff as well, right?
Yeah, I mean, just really quickly, the way that kind of works is computers like absolute numbers. I mean, if you have a loop and you're trying to loop through these items in a list and you loop from one to the size of the list, but you don't really know what the size is, the size could be changing. Computers, they can't optimize that because they don't really know every time they go through this loop, they don't know if this is going to be the last time or not. What a just-in-time compiler does is it's able to say, okay, I know that the size isn't going to change in the next millisecond. So I'm going to lock that down and I'm going to tell the system, the actual machine, that I'm looping from 1 to 30 instead of from 1 to the size of the list. And so, yeah, because of just-in-time compilation and being able to limit what things are changing and at what times, the actual machine is able to run much faster.
Interesting, interesting. Good stuff.
Yeah, do you have anything else to add on Python?
So much stuff to add, I'm sure, but I think we covered it fairly well. I mean, at least at a introductory level slash deep level, we kind of been bouncing around a little, but I think that's good. It'll cover all parts of our audience.
Yeah, I think that, you can, people who are just learning Python or learning programming for the first time can sort of go back later and learn more about, virtual machines and things like that by, listening to this podcast a second time. And people who are, really experts can hopefully learn one or two things from us today.
Definitely, and I'd be happy if they listened to it once. We'll worry about them listening to it the second time
That's
later.
right.
Let's get enough people listening to it the first time.
Yeah, that's right.
So on that, I guess as a conclusion, I don't know if you're listening to this. You probably found us on either our website or on iTunes, but we are now on iTunes, so that's a little bit of a yay.
Yeah, that's awesome.
And we're starting to get a few comments and ratings in. So if you like what you hear, or if you don't, remember Jason said how if you think we're terrible, just give us a 5-star rating and make us feel so bad that you think that we're terrible, and yet you still gave us a 5-star rating.
That's right.
And if you liked
Yeah,
us, give us a 5-star rating and tell us how great we did.
yeah, definitely. And if if you have any comments, you can email us programmingthrowdown@gmail.com, or you can post on our blog programmingthrowdown.blogspot.com.
Yeah, absolutely. In all fairness, we really would like to have any sort of criticisms you guys have, constructive or otherwise, just so that we can try to make this better. We're doing this to help you guys and to have a great time.
Yeah, definitely. Okay, so I guess that wraps this one up unless you have anything
All
else.
right, so that's us signing off.
See you guys later.
Bye.
The intro music is AXO by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.